Next, I'm addressing Tittu, Barbies, and Matthew. And I think we as I understand, you can welcome relatives from him coming from India just for the purpose of this ceremony. So welcome people. Tittu joined the chair in 2008 with a BSc in mechanical engineering, and he was working on his master thesis, miniaturization of micro thrusters for nanosatellite applications using MEMS technology. Through a cooperation that we have at our chair with a group of Professor Saro of IMES, which stands for Delft Institute of Microsystems and Nanoelectronics, we had access to their unique production facilities and excellent assistance from Dr. Mikhailovich. Now, in his research, Tittu demonstrated the feasibility of miniaturizing resistor jet thrusters to a very, very small package which just measures 25 by 5 by 1 millimeter, and that thruster has a mass of 160 milligrams. So tiny, tiny thrusters, which are of high interest for those tiny satellites we are developing. And they almost double the performance of what currently standard cold gas microthrusters are able to do. In addition, Tittu showed the potential of the device for further performance improvements with the capability of outperforming today's best chemical rocket systems in terms of mileage per liter of fuel. The joint work with a group of Professor Saro has led to 2 conference papers, one of which was presented in Beijing, and the other one recently in Cape Town. In addition, an invitation has been obtained to prepare a journal paper for a prestigious journal on nanotechnology. After spending some necessary time back home in India, Tittu is now back to take new challenges. And I'm happy to hand over to you the diploma of Master of Science in Aerospace Engineering. Now I'm addressing Walter Ewing. Is Walter here? Because I haven't seen his face. No? Walter? Not here? Okay, so then I think that concludes my talk. Thank you for your attention.
Thank you, Professor Gill. And next is Mark Potjer from Professor Stowe. But he couldn't easily be here, so I have the honor of giving you the floor. Let's make sure you get the right. Mark, you worked on UAVs. The title is Recommendations on the Certification Specifications of Unmanned Aerial Systems with Low Kinetic Energy and a maximum takeoff weight between 150 and 750 kilograms. It's also quite a summary this time. UAVs, as we often call them, I always call them also unmanned aerial vehicles. But I was once corrected by an American who said that it was not correct to call them as such because it was a sexist way to describe them. So I should have said uninhabited aerial vehicles. But you still call them unmanned. I think man also stands for man as the species, right? So anyway, so what is a UAV? I think I've got another slide there with my own UAV. Yes, that's my own UAV. The Easy Star, you know it? Okay, it's maybe better on the next slide because it's regularly seen as a toy, but it's no longer a toy, because we also see military working, not playing, but working with the same kind of toys. And this is a very light one and easy start. You can really be hit on your head without any trouble. But if we see the UAVs that you looked at, they are quite a bit heavier. And even though they are called, your title says low kinetic energy, I think the conversion of potential to kinetic energy with 150 kilograms or more still requires some attention. So, in other ways, it has to be certified. This really has to be certified carefully, and that's where you looked at. You also wanted to do something that is not just interesting from an academic point of view, from the curiosity, but you also wanted the practical application. So that's why you chose to work, as I'm told, one of the reasons, I guess, to go work at the Military Aviation Authority of the Netherlands, where you looked at the new requirements for certification, specifications for, well, they're still called small unmanned vehicles. I mean, they really are ones that have the same size as 737, right? In that sense, they are. I heard that basically your systematic analysis method, including your reporting techniques and your careful derivations, made quite an impression, and also led to an excellent thesis. During the discussions with your supervisor, you also showed that you do not master one, but you really master the whole scope of aeronautical engineering. You really cover many disciplines. And even that was not yet enough. You also, to even go deeper in other areas, you consulted internal and external experts from disciplines outside aerospace or other disciplines within aerospace, even to get to a high quality that you were able to do. Well, this resulted in an excellent grade. I mean, the committee was unanimous that this was really extremely high quality work. So you got an 8.5 for that from all the members of the committee. And it indeed will be used in practice. So you succeeded in that respect as well, from both from an academic perspective as well from doing something that really helps, because your certification specifications will actually be used by the NATO partners to certify this unmanned vehicle. So congratulations with it, and without further ado, I'd like to give you the diploma for the master. One more. You get the same diploma 3 times. Okay. It's just and the final one is Jacques Wildermast. And you have a slide that this with pictures. Yeah, Jacques Wildermast, you also worked at something that is really used in practice, right? Really used by a company. You see here wiring, and this is often forgotten by many people. The amount of wiring that goes into an aircraft is really huge. There are over tens of thousands of different signals which need to be processed. It's basically a flying computer nowadays, nearly every aircraft. And this actually means that we still have hundreds of kilometers of wire and thousands of connectors. And this means, because it is a substantial part of the weight of the aircraft, that it's also weight savings are useful there, and it needs to be designed with care. It's also a very complex system. It's easy to make a mistake in such a complex system, and they are made before they are put in the aircraft. And we have a company in the Netherlands, Fokker Elmo, one of the remnants of the Fokker. And this company has really a world international reputation for being able to develop the wiring for different aircraft. It's also considered for the Joint Strike Fighter as well. So really the high-end, very complex aircraft, the wiring is often made in the Netherlands. Not everybody knows it. It's still a lot of handwork, but also in the design, a lot of it still has to be done over and over again. And that is also one of the reasons that you tried to improve the design process by using what we call knowledge-based engineering, where part of the knowledge is in the computer now, and it assists in designing and optimizing the design of the wiring. And you worked on 2 deliverables. And one of the things that struck me when I read about the work that you did is the creativity you showed when coming up with names for your tools. It's a sort of hobby in our domain anyway to come up with creative acronyms. But you were really good at this game, because the first KDE application was called the connector selection instrument. This sounds like a logical name. And of course, if you look at the acronym, it's CSI, a sort of CSI Delft, right? That's an automation tool that can be used to select the connectors optimally for a group of signals using a set of standard connectors. But there was a second deliverable that was the optimization framework, and this, if you look at the full name, it doesn't immediately show, but then it's simply called the Automated Integrating Routing and Connector Optimization. In short, the AIRCO. We developed the AIRCO, right? And of course, it is indeed cooling the engineer when he uses this, because it lowers the stress of the designer, right? In a way, it is really an AIRCO for design engineers. Well, so this was one of the things they noted, your creativity. Otherwise, you're a relatively silent guy, but you really worked hard and were dedicated. And the examination committee, which consisted of people from Fokker Elmo, but also of KeyE Works, but this is actually a company that developed the tools for which you worked, right? They were very pleased with the results, and it will also be used in practice, so you also succeeded both, again, from the academic point of view and from the engineering point of view. And you really show how you can use what you've learned here immediately to address real-world problems in the industry, and include a Dutch company which already improved. So my congratulations with that, and for that I'm also happy to give you the diploma. Everybody should now have their diploma. If not, raise your hand. No, okay, we're fine. Then we now come to the closing part, and we need to be prepared for the more informal part, for the drink and the pictures taking outside. And there's no better person to do this than the president of our study society, Mr. Tom Willems. I always have difficulty changing language if you want to. Tom, thank you. Yours. No slides? No slides? Okay.
Dear Dean and Professors, dear family and relatives, but especially to you, dear Masters of Science in Aerospace Engineering. I'm Tom Willems, I'm the President of the VSV. And it's an honor to me to stand here today on behalf of the VSV Leonardo da Vinci and congratulate you with your title as Masters of Science in Aerospace Engineering. It may have been during the start of the freshman's weekend, or during your first lecture in statics or calculus, but it all started in this very room. For some of you, this moment was no more than 5 years ago. For the most of you, a little bit longer. But it all started with an enormous amount of enthusiasm and passion for aviation and space technology, which you still have. And I can be sure of this, because if you wouldn't, you'd never have gotten so far. Remember entering this room around 7 years ago, together with almost 300 other fresh first-year aerospace engineering students, and over half of them didn't make it. But you are still here, and you will be welcome in this faculty for the rest of your life. There are many ways that lead to a Master's of Science in a degree in aerospace. None of them are easy. Some of them are longer than other ways, but all of them will change an 18-year-old boy or girl into an educated and professional engineer. I hope you all started your time in Delft with at the VSV Freshman's Weekend, where you became a nullige, not knowing what to expect from your time as a student of this university. This was one of the biggest steps in your life, leaving your parents and starting an uncontrolled life of your own. After getting to know your fellow nulliges, the journey started and 1,000 choices had to be made. You may have chosen to join a fraternity, a sports society, or any other legal way to delay your study and stay a little bit longer in Delft than given 5 years. After that choice, dozens of parties, drinks and events were your occupations for the evenings after the lectures ended. No obligations to anyone, except for calling your parents every now and then to tell them that somehow your bank account was already empty and you still had 2 weeks left until the stupid wolf would fill it up again. During your life in Delft, you eventually learned to take responsibilities. Maybe you started a small business or did some work in a committee at your fraternity or at the VSV to develop your skills in organizing and managing events. The social aspect of studying in Delft has formed you into someone that not only knows how to create the perfect airflow, but also someone that with the knowledge of working with people and someone with a network full of other Delft engineers. These are a few of your most valuable tools as you leave Delft and start developing your qualities at your future employers. Remember that these future employers know that you have these tools and that they are prepared to do everything in their power to get you to work for them. The feeling of waking up this morning, knowing that you have finished one of the most challenging studies in Delft, and knowing that today your hard work will be rewarded with a Masters of Science degree must be astonishing. In your life as an aerospace student in Delft, you have conquered the laws of physics and mathematics. But without a doubt, you must have spent some time in some of the bars of this beautiful, small city. Waking up after a good night out with your friends, entering this room via the back door, acting as quiet as you can. Some of you may have had their hardest struggles keeping their eyes open, listening to the endless calculations and stories about the amazing world of aerospace engineering. Take a break once and think about your best moments in Delft. Was it everything you hoped for, or even more? What did you learn about yourself? And what kind of person have you become? But maybe even more important, who will you be in a few years? Today, a world full of new opportunities has opened, and the next steps are to be made. But I must warn you that once again, you are taking one of the biggest steps in your life. Make your decisions well, because the next chapter in your life will be controlled again by other people. Your agenda, and not to forget, every morning your alarm will decide if it's time to wake up or not. You are no longer a student. Sadly enough, you have become a civilian. As you will start at your new job, a whole new journey will begin. Suddenly your weekends will become the most important part of the week to enjoy your well-earned rest. Maybe you'll start a family, buy a house with a Honda Prius on the driveway. After waking up and driving the kids to school every day, your boss will tell you what to do and when you can go home or not. Back at home, your wife tells you to feed the dog, while the only thing you want to do is sit down on your couch, watch TV with a cold beer in your hand. No more beer crates in the living room. Don't even think about a special fridge for beers, as you were used to. But if you are at one of your friends' housewarming parties and someone asks you, what do you do in life? Then you can say, with a big smile on your face, yeah, I'm a rocket scientist. Of course, this is just one of many roads you could choose. Maybe that house will be an apartment in London, or that prize will be a Porsche. But whatever you choose in life, I wish you luck with your next steps. As president of the VSV, I want to address another change in your life. But this time a very sad one. Because from this day on, you are no longer a member of the VSV. How tragic this may be, there is a bright light at the horizon. This light is called the Delft Aerospace Alumni, short, the DA. Where the VSV organizes activities for aerospace students, the DA focuses on aerospace alumni. By becoming a member of the DA, you will have contact opportunities with other alumni via the DA website. We will keep you updated with the VSV activities that are also interesting to you as an aerospace engineer, like symposia and lectures. And you will keep receiving the Leonardo Times 4 times a year. From this day on, you can be part of the DA. Outside this room are laptops with a short subscription form waiting for you to become a member. But before you subscribe to the Delft Aerospace Alumni and write your names on the aircraft panel, I would like to take the opportunity to mention a few new Masters of Science in particular. During their life as aerospace students, these few have volunteered to support the VSV Leonardo da Vinci with their skills and enthusiasm. These former students have made all kinds of activities possible, like excursions, study tours, and parties. Without these people, the VSV wouldn't exist, and therefore, I want to thank them in person on behalf of the VSV Leonardo da Vinci. To do this, I'm going to switch to Dutch. Vanmiddag hebben we maar één voormalig actieve VSV onder ons. Dat is ingenieur Hamer. Ingenieur Hamer, in het jaar 2009 is dankzij jou